that's what we're going to do today. And do as much practice as we have time for. And this is the essentials. I'm using the convenient form of curl and div, the one with the operator delta. So the curl is a vector formed by the cross product, and div is a scalar formed by the dot product. Hold on a second. There we go, a little bit more light. And so what was I saying? Yes, curl and div, and that's your vector field, and that's your operator delta. And something we already know about, but to remind you again, a vector field F is called conservative if its curl of F is 0. So that's a test for it. When this is true, that means that there's going to be a potential function little f that has the property that delta of f is the vector function f, and delta of f is this fella, and f is PQR. So first question I'm going to do is like question 4. Here is our vector field. It's y cosine of xy. And then it's x cosine of xy. And then it's rather awkward -6 sine z. And in this question, we're going to be asked to show or find out, is this vector field a conservative one or not? So what I'm going to do is I'm going to find the curl, and if it's a 0 vector, then it is conservative. And then the second part of the question says, if it is, then find the potential function little f. So let's do the curl of f. It's set up as a 3x3 matrix determinant. You put in second, the operator. And lastly, you put P, Q, R. And y cosine of xy, x cosine of xy, and -6 sine z. We're all comfortable with that. It takes a little bit of time to write them down, but it's pretty standard, right? Nothing amazing. We're going to get so many i's, take away so many j's, plus so many k's. Okay, keep an eye on me here. In case I go wonky. That's 0, right? If you differentiate this with respect to y, you get 0. Take away. Oh, that was easy. Middle one. 0. Ooh, that's scary. If you go this way, then you go that way. I guess I'm going to have to do a partial derivative of this with respect to x. So that's something I don't think I can really do in my head. So here it is. With respect to x, then I'll do essentially a product rule on it. F dash j plus f of j dashed. That's going to be 1 times this cosine plus this guy times the derivative of this, which is what, negative the sine of xy. So it's a cosine of xy, take away x sine of xy. Okay, that's what the first piece is. Right, so going that way, then I'm going to subtract, and I'm going to subtract the derivative of this fella, which also happens to be a product rule. So it's 1 times the cosine of xy plus y times No one saw my mistake. Can anybody see the mistake that I made here? There's something missing here. What do you get when you
A Y?
You get a Y? Okay, at least I caught it. And this time you're going to get a cosine, you're going to minus sine xy. So that's going to be a cosine of xy minus xy, the sine of xy. And then remember, you're going to subtract it. Right, here goes. If you take this guy and you subtract this guy, since they're the same guy, would you agree after all that hard work I got 0? Right. First derivative, take away this derivative, which is exactly what we were hoping for. So f is conservative. If it wasn't, I'd get 0, 0, x sine y or something, right? I'd get something that wasn't 0. In which case you're meant to write in the word dne, or the letters dne. So it is possible that you're going to get a question like this where it's not a conservative field.
Are we subtracting the top derivative by the bottom derivative, or the bottom derivative subtracted the
Okay,
top
we
derivative?
are taking, let's do this last one. We are taking this derivative, subtract that derivative. This derivative is him, subtract this derivative, which is the other guy. And they are the same thing. So when you subtract two things at the same, you get 0. Okay, so
Yes.
this fellow with respect to x, take away this fellow with respect to y. Is that what you were asking?
Yes.
Right. So I guess I could put d by dx, which is the first guy, take away d by dy, the second guy. Well, we now have a conservative field, so that means there's a second part to this question. We're going to find the potential function. So I know that this function has the property that delta of it, in other words, this fella.
I have a quick question about the first part of that.
Sure.
So in WebAssign, will we enter the vector 0, or do we enter dne for that?
The answer doesn't get you to enter anything if it works. What you enter is the value of the potential function.
Okay.
So what you got in this question was you got the question and you had a box that looks like this, the potential function.
Okay, so that's okay.
So if it doesn't work, you put dne in here, and if it does work, you put whatever it is.
Okay.
So that's how it's going to get formatted. So we know that it's P, Q, and I. Okay, let's see. df by dx is going to be this guy. My second one says df by dy is going to be this guy. And my third one says df by dz is going to be this guy. So the process of using this information to create the potential function involves integration. Right, so I'm going to take this fella here and integrate him with respect to x. So what's that going to get me? Well, when you integrate a cosine, you get a sine. Do I get anything else? Because it's a cosine of xy. And it's a bit like the cosine of 5x or 10x. What else do you get when you integrate the cosine of xy? Don't just get the sine of xy.
The leading y would actually go away, right?
But this one? No. Not sure where that idea is coming from.
Well, the chain rule.
Oh, you mean because of what you're about to do? Yes. What you're about to do is divide by y. Now I know what you mean, right? That's what you meant?
Yeah.
Yes, I agree with you. It's just my brain wasn't functioning. Technically, plus a function that doesn't have an x in it. You know, that's just a placeholder. Right, this fella. Very similar answer. What you're going to get is you're going to get the sine of xy divided by x, which gives you the sine of xy, plus a function that doesn't have y's in it. And this fella, well, you're going to get a positive 6 cosine when you integrate it, plus a function that doesn't have an x and y in it. And when we merge all those together, we will have our potential function. So I got a sine, I got the same sine, and I got this guy. So sine of xy plus 6 cosine z is the potential function. Are we okay with that process? Right.
I have
I
a
did.
question.
Yes, Lindsay.
In the last section, we didn't really do the test for conservativeness for a three-dimensional field. So is that basically, would that have been finding the curl?
Yes.
Okay.
But you didn't know how to do a curl when they were asking that question. So they just assumed it's okay, you can do it.
Okay.
But now it's not okay, because now you can test if it's okay, right? Because it may not be okay. Are we cool with this guy? Right. Now, as you can imagine, they're kind of long. They do take some time, but they are a process, and I like process because that means they just change the functions. They don't really change much else. So let's find another one of those. I want that one. Try to find. Yeah, why not? This one is 14. This fella is xyz squared, x cubed yz squared. Beginning to regret picking it now. X cubed y squared z. And it's the same question. Find out if it's a conservative field or not, and if it is a conservative field, find the potential function. So we're going to find the curl of f. So set them up the way you do all of them. The first guy goes here. Second guy goes here. I know what my scanning's like, so x, y, z squared, check. X cubed y, z squared, check. X cubed y squared z, check. Okay, so we got that, and darn it in space. I forgot to put my operator in. Right, so that's a bit crunched, but it is there. Right, you trust me, it is there, the operator. The delta guy. Okay. It's going to be a
How
bit.
do you find that delta guy?
How do you find the delta guy?
It's just the d by dx.
D by dy, d by dz. Right, cover this guy up. Differentiate this piece with respect to y, and you get xz. Take away this fella with respect to z, and that gets you 2x cubed yz. Let me double check that. This guy is x cubed z. That's better. And this guy is 2x cubed yz. Okay. I'm not doing anymore. Why do I not need to do anymore?
They're symmetrical.
No. They might be, but that's not the reason. I'm I'm testing to see whether it's a conservative field. If it is a conservative field, doesn't that have to be 0?
Agreed.
And if that's not 0, do I care if the other two are 0 or not?
No.
No. So, not conservative. Which means that you will put in the box where right next to the potential function a DNE. Now, I'm just going to put on the solution here. I'm pretty comfortable with what I just did unless I scanned it wrong. It's question 14. Just jump to it.
Professor,
It's not conservative. Yes.
can we redo that one more time? Because I got
I will
another
do it
question.
big because it's very
Okay.
crunched.
Yeah.
So here is the operator, nice and big. Oops.
X to the third, y squared, z. Yeah. Make sure we
Now,
keep-
this fella is,
Okay, the last one is a y squared. It's x to the third y squared z.
the third one. I've lost the guy.
So for the k,
Okay.
on the third line,
I think I did this one already, and I had this problem too because the P, Q, and R are so similar.
yeah.
Okay, I'm trying to make sure because I have horrible problems.
Your
Oh.
R is x cubed y squared
Y
z,
squared.
Thank you.
and you have x cubed y z. Should be the y should be squared. There you go.
There you go.
This good? This good? This good?
Yeah. Yep. Yep. That's
Okay.
good.
All is
Okay.
good now.
All is good. Right, so
Just for that.
this guy, take away this guy. A lot of this I do in my head, but obviously I'm not very good at doing things in my head. Right, this fella ends up being x cubed z. And this fella ends up being 2x cubed yz. Clearly not equal, clearly not a conservative field because of that. Right? That's just the first term.
No, wait.
So the dy,
The dy would be, because now you have that y squared
you had that y squared, yeah.
to y x cubed
What y squared?
z.
Oh,
You dropped
here,
the y squared again where it says
I would drop my y squared again.
And now z
Not
has
that
to be
one.
squared, and that
The
does
first
not
one.
in the original function.
and your dy d
Yeah,
by
yeah,
dy
yeah, yeah.
function.
There we go. Okay, now you're good.
I wish I hadn't done this question now. I'm really regretting it. Is that the guys that we now have?
No.
That guy gets you this, and that guy gets you this.
Oh shoot, I think I screwed you up when I corrected you actually.
So it should be dy times
Okay,
x cubed.
let's time out. Whatever the first guy is, take away whatever the second guy is. It ain't 0, so it's not conservative. You have a shot at it yourself. Trust me, it ain't working. And the answer agrees with me. And I'm just fed up changing letters of the alphabet. So I'm getting grumpy now because that question's annoying me. But that's not your fault. I'm not grumpy at you. I'm grumpy at me. So let's move on because we.
Can I ask another question before we do?
You can, yes.
Finding curl with a two-dimensional field where it's just like I and J and there's no K.
Right.
How can we do that?
Okay, let's show you how that would work. Let's call it P and Q. And since it's two-dimensional, this will be, that will be this guy, right? When you set up your, what you would think this fella, right? You don't need the I's and J's. You just need these guys. So what you get is this guy take away that guy, which is the test that you used when it was two-dimensional.
Okay.
Does that make sense?
Yeah.
When you go three-dimensional, the world changes a little bit, so you need the I, J, and K, because your answer in that world is three-dimensional. So the curl, when you're doing a two-dimensional, is a single thing, a scalar. But when you do a curl in higher dimensions, your curl is a vector. Okay, let's do a curl and div of somebody. Somebody that doesn't make me growl. Ooh, that's a cool one. Let's do this one. Our vector field is this ugly guy. Before I continue with this, there is something that's going to make my life a lot simpler. Do you notice that this function is essentially symmetric? So I should be able to figure out from that how to simplify my life a little bit, right? How we can use one answer to generate the others. Right, so let's go for the curl. Keep your eye open for me screwing up at the beginning, and we'll see what happens later on. I, J, K, check. The operators, check. 2x over ugly square root, 2y over ugly square root, 2z over ugly square root. Agreed? Nothing screwed up so far? Right. Then, oops. So many i's, take away so many j's, plus so many k's. So if I cover this guy up, I'm going to differentiate this with respect to y, take away this with respect to z. So since that is a little bit messy, let me write down what that is going to be. I'm going to differentiate 2z over the square root of these guys, take away this guy, okay, if you're going to differentiate this, you probably should rewrite it like that. Now, since you're going to differentiate it with respect to y, you might even choose to rewrite it as that guy, because then I can just do a chain rule on it. Great. So you multiply it, and what do you get? This guy times negative half gets you negative z. You have x squared plus y squared plus z squared to the power of half, times the derivative, which gets you a 2y. And so you get negative 2xy, essentially the square root of x squared plus y squared plus z squared. That's the first guy.
Wait, why does it become a positive to the 1/2?
This is a very good question, to which I have no answer because I was wrong.
Yeah, shit. No, you were right. Right?
And I'm differentiating. When you differentiate, you reduce one, not add one. So I'll just leave it in that form. All right, this fella is going to be the derivative with respect to z of 2y.
Professor, shouldn't that be minus 2yz instead of minus 2xy for the last line?
Yes, it is. Thank you.
Thank you.
2xz. Oh,
YZ.
I've just decided that I can do the second one through symmetry. This, right, rewrite this down. This is what we got after a few fixes. And this was that guy. I bet you a bottom dollar that this fella here is going to be 2. If you want to pretend the letters go the other way around, you can. The same thing to -3/2, which means you're going to get you're going to get 0. If you just take this guy and switch the x's and z's, they're cancelling. But you can double check it, but I'm sure it is. So I bet you if one of them's 0 by symmetry, won't the other two be 0? Right. So if I haven't convinced you this one is 0 by symmetry, well, you just do it the long way and get 0. But if this one is 0, would you say that by symmetry, the other two being 0 would be a better logical leap? Which brings us to how to find the potential function. So we are going to be looking at and I'm going to use symmetry again. If I can use just the first function, this guy here, to generate the first answer, shouldn't I be able to use symmetry to make a prediction on what the other two would get me and save some time? So if this guy is equal to that, to find f, won't I have to integrate? With respect to x. How am I going to integrate this thing with respect to x?
Use substitution.
Yeah. And although it looks big, and it is kind of slightly big and ugly, it doesn't actually, comes out actually quite nice. So it's the integral of 2x square root of u times 1 over 2x du. All of this cancels, and it looks like this, which I will then convert into this. And now I have my integration hat on. Add 1 to the power, divide by the new power. That becomes that fella, which in turn becomes that fella. So f is this guy plus a constant that doesn't have an x in it. By symmetry, would it be fair to assume that the next question would generate, or the next part of the puzzle would generate the same guys? Plus somebody who doesn't have a y in it, plus an arbitrary constant that doesn't have a z in it. So here is our potential function. Now that actually went quite clean. Let's pretend that we got a different answer. Still got symmetry. Can we pretend that we got an answer right, when we did the df by dx version, that we got the answer 2yz square root of ugly guy. Could happen, right? Different question. If we did the next one, right, so that's what we got from here. If we did this one, and then finally we did this one, these bits would stay the put. If this one was yz, what's the middle one going to be by symmetry?
XZ.
And the third one, xy. You know how symmetry, how it works, how you can use symmetry to generate two other answers. So if that had happened, wouldn't our answer be that guy plus that guy plus that guy, because the three of them are slightly different from each other? But you know the arbitrary constant part that we put over here? Don't they catch the other two? So at any given point, the other two functions are there. Are we good with the symmetry if you can see it trick? Otherwise, you just do it the usual way and it takes a little bit longer. Any questions about that one? Right, now, a thought just came to me, so I'll put it out here right now. I was looking over, because typically I don't, because I don't find it very useful for me, how the textbook did the same process of finding potential functions. And they don't do it quite the way I did it, which was interesting. And I didn't like the way that they did it either. But I'm putting it out there that if you go looking at the textbook, you'll find that there is another approach to finding the potential function. And maybe it will work better for you. Maybe the way I do it is just a little vague for you. So if you want to, have a look at it, see if the way the textbook does the solutions to one of these questions, the potential function part at least. And there, you've got another technique that you can use. Are we good with this question so far? Right. So let's do some more curls and divs. Don't know what I'm doing here. I'm just randomly zooming around for no particular reason. This is the last question. Not that that makes it any less significant. It's an x plus yz. It's a y plus xz. And it's a z plus xy. And let's do a div first. If you call this P, you call this Q, and you call this R, then this guy plus this guy plus this guy is the div. Right, if you differentiate this with respect to x, you get that. If you differentiate the middle one with respect to y, you get that. And if you do the last one with respect to z, you get that. So there's not a lot of work in the div, right? At least this one. Now I'll do a curl. These questions are not asking you to find any potential functions if they exist. They just want you to find the div and curl and call it good. So put in my operators.
Professor, I'm confused. When
Yes.
you took the derivative of the function, say the first part, with respect to x, wouldn't it just be 1? Because it's addition?
Correct. I'm not having a good day today, am I? Which one have I missed? X, Y, X, Z, Y, Z. There we go. in no particular order, but you get an extra 1 in each case.
Wouldn't it
Well-
just be 3 then? Because
Yeah.
Well, it'd be 3 plus these. You get 1, 2, and 3, but these are still there. Oh God! Oh bloody heck in space! I have no idea what's wrong with my brain today. I think I should have stayed in bed. Right, I'm going to finish this curl correctly. I'm going to have to get one piece right, make me feel better. I think I'm too busy focusing on something else in my head that's totally not necessary. Right. If you do this guy with respect to y, he disappears and you get an x. Gotcha. Takeaway, if you do this guy with respect to z, he disappears and you get an x. Oh, so 0. So many i's. Takeaway, so many j's, plus so many k's. Okay, let's go for the middle one then. If you differentiate this guy with respect to x, you just get y. And if you differentiate this guy with respect to z, you get y, which gets you 0. If you differentiate this with respect to x, you get z. And if you differentiate this with respect to y, you get z and you get 0. Which is nice to know. Essentially, although you don't need to know for this question, isn't this thing a conservative field? You agree? Quite a nice conservative field. A little bit of symmetry to it. Where shall I zoom off to now? Really, it's
Question.
you got a question?
I do. I
Go
do.
for it.
So for the 2D field where if we just have I and J and we want to find the curl for that, we drop the I, J, and K in the top row. But that would work for any, I guess, if we only had 2 of any of them, that setup would work, right? Like if we had I and K, we would just do DX and DZ. And if we had J and K, we would do DDY and DDZ.
So when you're saying that, what you're saying is that you're taking a 3D field, but you're only going to use 2 of the variables.
Yeah, like say
So
Xi,
what you've
Y.
got there is a 2-dimensional plane in a 3-dimensional world,
Yes.
and on that 2-dimensional plane, there's some kind of function.
Yes.
The curl still exists because it's still a 3D field. So you shouldn't do that, because if you do it, all you will get is one term, which is fine, right? Because if you eliminate the I, J, K and just focus on it, you just get a Sagela. What that will mean is that your curl will be 0 something 0, or something 0 0, or 0 0 something. In other words, the one thing that you found will either be in the X, the Y, or the Z position, depending on which I, J, K combination of 2 you picked. So it's still a 3-dimensional curl, just 2 of the numbers happen to be 0. So technically you should still do it.
Could you go over like a question like 13 or 16? Because that's what those are.
Ah, okay. That would, right. 13 is, you have a vector field, and it has that X, no Y's, no J's, and it has that guy. So the way you treat it is just the way you treat all 3-dimensional vector fields. The fact that there's a missing middle term, geometrically, that just means it's a 2-dimensional, there's only 2 dimensions in the vectors that are being used, but the third one is still there, it's still 0. So you find the curl and the div in the same way that I do all of them. So let's do a curl. you're going to do I giant K. I think part of the confusion is that when you do a two-dimensional curl, right, that is a two-dimensional vector field, right, an F that only lives in 2 dimensions. The I and J don't really matter. Anyway, let's put this fella back in. You have this fella, you have this fella, you have this fella. And then you have this fella, a 0, which is going to be quite important. And then this guy. Now, there is nothing I've done here that is any different from what I would have done if that had been x cubed. Right? I'm still doing the same 3D process. So it's going to be so many i's, take away so many j's, plus so many k's. Now, based on previous experience, I should be careful. If you differentiate this, you get negative x squared, take away nothing. If you differentiate this with respect to x, you get negative 2xy, take away an xy. And if you differentiate this, you get nothing, take away an xz. So it ends up being negative x squared, positive 3xy. So it didn't even have zeros. Interesting. I thought it would have some zeros, but I'm wrong. Unless I screwed up, I hope I haven't. So do you see, I don't treat it any differently.
Yeah, that makes sense.
Now, if you had a vector field that was xy squared 0, 0, a weird vector field, but if you had one that just looked like that, right? If I did the curl on it, can you see that I'm probably going to get 0, 0, 0? You could do the math of it. I'm just curious what that would do. You got me thinking here. I wonder what the curl of a function where all 3 things are the same thing, in this case x, would be. We'll find out. Shouldn't take too long. It's quite an easy one to do.
I wonder if that would be conservative.
I'm wondering. I'm wondering it myself. I don't know. I guess I'll find out in the first term. 0 take away 0. Maybe not in the first term. Just because the first one's 0 doesn't make the other ones guaranteed. 1 take away 0. 1 take away 0. So what you get is not a conservative field. Interesting.
Weird.
And weird, totally weird. Because what that would mean is that this basically, this vector field here, at any point in 3D space, the vector is just pointing in the direction of whatever the x coordinate is. So it's like pointing at 5, 5, 5, 7, 7, 7. So it would be a whole load of vectors shooting outwards and getting bigger, except along the axes. You know, the x-axis when it was 0. And going vertically upwards, that would be a weird vector field. I'm trying to imagine it. It would be exploding in certain dimensions and then non-existent along some of the axes. Weird function. Okay, we do not have enough time to do one more because we've got about 3 minutes left. Is there anything, because this is as much time as I can devote to this, anything that you want to ask about curl and div before we finish?
I think I asked what I had to ask.
You're happy with the asking? Okay. If you're careful, unlike me, it is a process that you just follow and things are fine, right? So take some comfort from that. If you know how to do the process, and you're careful, everything will come out right in the end. And I'll hang about for any other questions. Hopefully you've already said hi.